All right, we have the second series of Iupac nomenclature. So how can we name this following compounds? Don't forget, the first thing to do is to follow your longest carbon chain. All right. So after you locate your longest carbon chain, you number the longest carbon chain forward and backward. After numbering it forward and backward, then you locate your substituents. Now, and I said that substance can be of two kinds. It can be an alkyl or it is a functional group. Okay, when it's an alkyl, probably it's an alkane that has lost one hydrogen atom. Then when it is a functional group, you have something like in, ein, oik, nal, ol, halides, and the likes of it. Those are functional groups. Okay, probably in our next class, I'll teach you how you operate this functional group better. But today, I'll be focusing on how to name alkenes generally. Alkenes generally. So let's see one or two questions on alkenes. But the first question we'll be picking is alkane, purely alkane. So let's see. Now, I have this compound. This is my first compound. So I'm counting the longest carbon chain. That's the first thing I'm doing. So counting the longest carbon chain I have, 1, 2, 3, 4. I can go that way, which is a straight chain. Now, if I decide to branch, I can branch this way, 1, 2, 3, 4. Now, note that once you count here, you cannot branch here because there's no bond between this and this. Okay, so you cannot branch this way. So what are you going to have? You can only have 1, 2, 3, 4. Okay, or 1, 2, 3, 4. Okay, now this is a starting point. So I've used one starting point. So I want to test the other starting point. Now, sometimes if you only use one starting point, you might get it wrong. Okay, so you have to test all the starting points. Don't forget that you can open this chain as C, C, H, 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 which will still represent C to H5. But I don't want to open it, so I can decide to leave it like this and name it. That makes sense. So if I use this as starting point, it means that one carbon is at the end, which can be a starting point. So that carbon, I can start 1, 2, 3, 4, 5, which means that from this starting point, I'm having a longer one. Does that make sense? Which is 5. Can I change my starting point? The answer is yes. Which other starting point? This is a starting point. This cannot be your starting point. Why? Because it's connected to two other carbons. It's as simple as that. This is telling you that this is a starting point. So if I start with this, I'm going to have 1, 2, 3, 4, 5, provided I branched. Okay. So if I go this way, 1, 2, 3, 4, which is a shorter chain. So which means that I should follow this chain because it's the longest carbon chain has at present. So let's number it. Once I locate the longest carbon chain, the next thing is to number forward and backward. So I'm numbering 1, 2, 3, 4, and 5. So what's the next thing? Number backward. 1, 2, 3, 4, and 5. This is the numbering. Now, the next thing to do is to locate your substituents. How many substituents do we have? Now, we have a substituent here because it's a carbon that does not fall as part of the longest carbon chain. Now, a carbon that is not part of the longest carbon chain is actually a substituent. So, locate the substituents. This is a substituent. It's as simple as that. Then, this Cl is also a substituent, but the kind of substituent it is not an alkyl, it's a functional group. What do? Circle it. It's as simple as that. Now, it means that I have two substituents in this compound. So, this is a methyl and this is chloro. This is a functional group. Which one? Since I know that, okay, before that, let's quickly locate the number to which they are connected. Now, we have 3 and we have 3 here. Both of them are connected to this particular carbon, which is part of the longest carbon chain. So the carbon that you're tracing that they must be connected to must be part of your longest carbon chain, which is this is connected to this is also connected to this. In that sense, what do? You have to cancel one of the numbers. Does that make sense? So which one can you cancel? You see, when the numbers are 3, 3, okay, you check your substituents. If the substituents are falling on, like for this example now, the substituents are falling on this particular carbon. So you won't have any problem cancelling any of the number. Do you understand? But let's assume that only chlorine here is on this carbon and the other carbon, this CH3 is on another carbon entirely, right? It will pose a problem, which one to pick, which number to pick. So in that sense, what you do is that you pick, you leave it okay? Then you go to the next substituent to see which one is the lowest value. Then once you pick that lowest value, you now trace it to which 3 is corresponding to the lowest value. That makes sense. Probably in our next class, I'll bring such example. Now, what am I going to do? Since I have now gotten to know that both substituents are falling on the same carbon atom, so let me just pick anyone. I'm just picking anyone. Okay, I'm picking 3. This 3, which is at the top here, which means that this 3 is connected to the whole of this. Hence, I'm cancelling this number. Okay, once I cancel it out, once I wipe out the number, I'll have a system of number, which would be the remaining ones. So how do I name it? Now, for me to write the name of the compound, I know that this chlorine is falling on carbon 3. This methyl too is falling on carbon 3. But which one am I going to give priority? Do you understand? Normally, you're supposed to give this one priority over this because this is a functional group. This is just an alkyl. This is not even formed from a functional group. The alkyl is coming from alkane. Alkane is not a functional group on its own. Do you understand? So you give this one the priority first. So we have chloro before methyl. Another reason, apart from that priority, another reason is because C, chloro, if you write the name C, which is chloro, and you have methyl, you observe that in alphabetical order, chloro is coming before meth. Hence, I'm going to write chloro first. So in that sense, what am I going to have? I'm going to have the name to be 3-chloro. 3-chloro, right? Then, what am I having next? 3-methyl. What's now the longest carbon chain? Once you account for the chloro, the substituent, the next thing you have to account for is the longest carbon chain. The longest carbon chain happens to be 5. Don't forget, in the compound, we didn't have any double bond, okay? We have everything to be single bond. And because we have everything to be single bond, it's an ane. It is saturated. Hence, what am I going to have? I'm going to have pentane. And it's as simple as this. Bam, I'm done. Now, let's go to the next compound. Okay, this compound, observe it very well. We have a double bond there, right? And because we have a double bond there, right, we have to take this into cognizance. We have to, how am I going to put it again? We have to take note of it, okay? So, how can I count the longest carbon chain? The first thing I am going to do, irrespective of whether there is a functional group or anything there, I'm going to count my longest carbon chain. So how am I going to count? I have 1, 2, 3, 4. So I'm counting from here because it's a starting point. Okay, 1, 2, 3, 4. Okay, can I go another way by branching? So I have 1, 2, 3. Still using this. Okay, that's the only 2 ways I can count. Let me use this as a starting point. 1, 2, 3, or 1, 2, 3, 4. So I can go this way or I go straight. But I know that most students will prefer to go straight. So let's go straight using the straight chain. So we are numbering the straight chain. We're having 1, 2, 3, 4. 1, 2, 3, 4. So I've numbered it forward and I've numbered it what? Backward. Now, the next thing is to locate my substituent. So the substituent I have, this is a carbon that is not numbered. Hence, it will be a substituent. This chlorine is a non-hydrogen atom, hence is a substituent, right? Then the last substance we have is an ane. The reason we've not been picking any alkane as a substituent is because alkanes are not part of the functional groups that we have. But ane is part of the functional groups we have. Do you understand? So because ane is part of the functional groups that we have to count it as one of our functional group, which is one of our substances. In other words, we have about 3 substances, 1, 2, and this guy here, which is 3, which is the double bond. The double bond on its own is a functional group. So what are we going to do next? We are going to give it numbers, okay? Now, there's something I want to show you quickly. You see, this ene is a parent's name because it's coming from alkane. Do you understand? And that parent's name can only end as a suffix. It cannot end as a prefix. You see this chloro here, we used it as a prefix, which means that it's not ending the name of the compound. We use this methyl as a prefix. But so here we are going to use it as a prefix, this methyl. We're going to use this guy too as a prefix, okay? But this double bond cannot be used as a prefix because it cannot change. Like, how am I going to put it? This double bond must always be a suffix. It cannot be a prefix. as we undergo studies on organic chemistry, I'm going to show you more things about these guys. Now, what are we going to have? We are going to have, since we have this, okay, we know that the longest carbon chain. So let's pick our numbers. Okay. Now, the first number you're going to pick is for this in. Why? Because the in is greater than this functional group. Both of them are functional group. This is not a functional group. So this will be the last thing you're going to consider. This one is a functional group, right? Because it's a functional group, it has priority over the halides. Okay. How do I know that it has priority over the halides? Or how do I know that it should be prioritized over this? I would show that in our next class. Okay. Now, since I know that this one is having the highest value, I'm going to ask myself, these two guys, are they on this double bond? Is it actually on a carbon or between two carbons? Now, you can all say that it is between two carbons, which means that I'm taking 4 numbers into consideration. This, because it's between the two carbons. Hence, what am I going to have? I'm going to have this, out of the 4 numbers, I'm going to have this as the lowest possible number. Because I have picked this, it means that this number here, the upper number, becomes useless. Hence, I'm going to clean this, right? I'm going to clean the whole of this. I'm going to clean the whole of this. What is going to happen next? I'm going to have the name of the compound. So which means that the in must take number 1. The chloro here is opportune like to have the number 1 because it's falling on the first carbon. Do you understand? If it's falling here, it will take number 4 because it's not on this number. Do you understand? It is going to take number 4. Does that make sense? But since it's falling here, it's going to take number 1. And then this guy has no choice than to take 3. Of course, if you number backward before, you have 1, 2, which means that it's, despite the 2 was here initially, it cannot take the 2. It will have to respect this numbering because the most prioritized has taken the number already. So once the most prioritized take the number, every other number in that system is applied to every other thing. Every other thing takes other numbers. That's how it works. Hence, what am I going to have? I'm going to have this done. So it means I'm going to have chloro. I'm working alphabetically now, right? Chloro before methyl. Does that make sense? In the writing of the name, okay? So I have 1 chloro. Oh, 1 chloro. Then the next thing I have is 3 methyl. And the longest carbon chain is both. But the kind of both it is now, it's not going to be butane because the N has been override by this in. So it will be but. What's the position of the in? But 1 in. Or you call it 1 chloro, 3 methyl, but in, which means that 1x and x are still the same. Okay, so I just made the 1 invisible. But if it is 2, don't make it invisible. Does that make sense? Write as 2 but in. Does that make sense? Okay, the next compound I have is this. So how can we name this compound? I have the longest carbon chain. I have 1, 2, 3, 4. Okay, I'm numbering now. 1, 2, 3, and 4. So I'm numbering backward. 1, 2, 3, and 4. I don't have any branch in there. But I have substituents. I have functional groups. The first functional group I have is the oic. Okay? Now, the fact that I circled it does not mean that you shouldn't count the carbon. The carbon should be counted as part of the longest carbon chain. So the carbon is not part of what I want. I'm actually. Then the next one is this guy, which is hydroxy. And the last one is what? In. Now, in the functional group priority, in the priority of functional group, we have the oic, which is the oic acid, right? The oic to be the most prioritized. And we have the ol to be the next prioritized. Then we have in as a third one. So we have 3 functional groups. 1, 2, and 3. Okay, this guy is not a functional group. Alkane is not a functional group. Hence, how am I going to write a name? You see, this guy is going to take the suffix, right, over this guy. Okay, if if we have these two in a compound, this particular all, which is hydroxyl, right? Is that we if let me make this clear. If the OH is going to end the name of the compound, okay, it's going to end with all, right? But if it's not going to end the name of the compound, instead of writing it as all, write as hydroxyl. Do you understand? So in this sense, it means that if I will name the compound, now before naming the compound, the last one, which is the in, what will happen to the in? The in too cannot take a prefix, but despite cannot take a prefix does not mean that while taking suffix it will override this. No, this is the highest in the series. Okay, so you push it to suffix, but there is a way you write it in a way that this will still be showing that this is more prioritized than it. Does that make sense? Had it been it has a name for prefix, we would have pushed it to prefix, right? So let's name the compound. So the longest carbon chain happened to be 1, 2, 3, 4, which is both. But then this should come as a prefix. The reason we are pushing it to prefix is because it has other name that it can bear as a prefix. Hence, I'm going to have, let me pick the number. The number here is the lowest possible number, which means that this 4, 3, 2, and 1 will be wiped out. In that sense, what am I going to have? So for the hydroxyl, I'm going to have 2 hydroxyl, which is the position 2 hydroxyl. Okay, now this is a suffix, this is a suffix. It means that I will name the longest carbon chain. So I have but what? It's not going to be butan, because an is telling you alkane. Now it's going to be but-in. Now, what's the number of the in? I have but 2 in the oic, which is the oic acid, because this tells you is an acid, and the kind of acid is an organic acid. Does that make sense? So I will write as but 2 in 1 oic. Okay, 1 oic acid. 1 oic acid. Or you just write as 2 hydroxyl, but 2 enoic acid. Instead of writing the 1, you just throw away the 1. Then you have enoic acid. This is the naming of this particular compound. So let's go to the last one for today's class. So what are we going to have? Have the longest carbon chain. So the highly prioritized, or the most prioritized here is the in, right? So let me write as a red ink. Okay, so it means that I can count the longest carbon. This is not a carbon atom, this is not a carbon, these are chlorines. So count the longest carbon chain. I'll have 1, 2, and I have 3. 1, 2, and I have 3. Does that make sense? So I'm picking the lowest here, which means that this 3, 2, and 1 will not work for it. So in that sense, it tells me that I'm going to have the in to carry 1, because between 1 and 2, it must carry the lowest possible number, despite it's falling between the 2 carbon. So that's what will happen. Then this chlorine are going to carry 3, 3, 3. Why? Because they are connected to carbon 3. Hence, what will be the name of the compound? I'm going to have, the longest thing is prop, is a prop something, right? So I'm going to have 3. The first 3 represent the first chlorine. The second 3 will represent the second chlorine connected to carbon 3. The third 3 will represent the third chlorine connected to carbon 3. So I have 3, 3, 3. Because I have 3 chlorine, I'm going to call it a tri. Hence, I have trichloro. Then, what's the next name? This in, I cannot bring it in. It must be an ending name. Hence, I have 1, 2, 3, which is prop. So I have prop. What kind of in? Prop 1 in, or you call it prop in, and it's as simple as that. All right. I think this helps, right, in the naming of organic compounds. See you in the next one, and enjoy the rest of your day. Bye.